In this video, we'll be talking about probability and proportions. So we'll set up a proportion to make a prediction for multiple events, or knowing the probability of one situation, we can make a prediction for something bigger or a larger number of times. So sometimes, after knowing the probability, of an event, it is helpful to know how many times the event will happen for a larger number of times. To answer this question, we can set up a proportion Theoretical probability of an event is what we want out of the number of outcomes possible. So a theoretical probability is how many times the event happened out of possible outcomes. For instance, the probability of tossing a coin, getting heads or tails will be 1 out of 2. Getting any number on the dice will be 1 out of 6 out of regular dice. So knowing the actual theoretical probability, we can see what happens if we have a larger number of successes or the events. To the number of times possible. Let's see an example how that works. So the probability of flipping a coin twice and getting heads is 1 out of 4. So that is the given ratio for the theoretical probability of getting heads as 1 out of 4. If you want to get heads 300 times, so if I want the heads to happen 300 times, so for the larger number, how many flips would you expect? The question is, how many flips will it take? To solve, we will cross multiply, so 1x on one side equal 4 times 300 the other way. To solve proportions, we use cross products. 1x equals 1,200. Then 1x is x, or divide by 1. We are going to have 1,200 times. So how many flips would you expect? You would have to flip the coin 1,200 times to have the expectation of 300 heads. So for the answer, you would say 1,200 flips. Let's see some more examples. For each of these problems, we are going to highlight the key information that fits the proportion. We're going to set up the proportion, label x for the missing value, and then solve the proportion. So for example, the probability of rolling 2 dice and getting doubles, so the doubles is what we're getting, either 2 1s or 2 2s or 2 3s, is 6 out of 36. So I'm gonna label, so that is the probability of getting doubles, 6 out of 36. If you want the dice, if you roll the dice 150 times, how many doubles would you expect? So the question is, how many doubles would you expect? In line with doubles, I don't know, but I'm going to roll the dice 150 times. Then we cross multiply to solve. 36 goes with x, 36x one way. Cross multiply 6 times, 150. 6 times 150, 900. Divide by 36. 25 doubles. So the x equals 25. If we read the question, how many doubles would you expect? Well, you would expect 25 doubles. The probability of rolling 2 dice and getting a number larger than 10 is 3 out of 36. So a number larger than 10 is 3 out of 36. If you roll the dice 300 times, how many numbers larger than 10 would you expect? So the number of times 300. And the question is, how many numbers larger than 10 would you expect? That is our question. I put greater than 10. Cross multiply to solve. 36 coming across with x on one side, 3 times 300 on the other. So we'll multiply and then divide by 36. X will be 3 times 300. We multiply 900 and then divide by 36. That will be 25. How many numbers larger than 10 would you expect? You would expect 25 numbers. Expect 25 numbers larger than 10. The probability of drawing a random card from a deck of cards and getting an ace is 1 out of 13. So the probability of getting an ace is 1 out of 13. If you draw and put back a card 200 times, the question is, how many aces would you expect? So lined up with aces, I don't know. I'm going to have my variable. X. So if the probability of drawing an ace is 1 out of 13, how many aces would be drawn if we draw 200 times? 13 times x, we cross multiply, 1 times 200, and then divide by 13 to solve for x. 1 times 200 is 200, right? And then divide by 13, we have a decimal number. So we're going to say approximately 15 aces. So we can have rounded to the whole number. So how many aces would you expect? Expect 15 aces, or 15 times the ace to be drawn. The probability of drawing a random card on a deck is getting a face card is 3 out of 13. So if we draw a card and it's a face card, jack, queen, or king, that is the probability. So I'm going to label. So here I have my face cards, 3 out of 13. If you draw and put back a card 100 times, how many face cards, so lined up with face cards, I don't know how many, but I can make a prediction by setting up the proportion and using the variable for the number of face cards. 13x will be one way multiplied and 3 times 100 the other way. So we'll multiply 3 times 100 and then divide by 13. And that will be our x value. 3 times 100, 300, and then divide by 13. And we have that decimal number again, so we're going to round it to the whole number 23 times. So 23, how many face cards would you expect? 23 face cards. If you're drawing the cards 100 times, expect to be drawn 23 face cards. Let's reverse the question a little bit and see what if the probability that it snows on a day like today is 1 out of 20. So the snow day like today, a probability to snow is 1 out of 20 days. If we want to have 3 days that snow, so this time I know that I want the 3 days to snow, how many days would have to pass? So that is how many days total. So 1 snow out of 20 days, 3 snow, how many days would have to pass? Cross multiply, 1x, 3 times 20 the other way, and then divide by 1, and our x will be the number of days. 60, 3 times 20, 60, divide by 1. So the question was, how many days would have to pass? 60 days. Colorado has about 1 in 125 chance that a small earthquake will happen in any day, on any day. So I have 1 chance out of 125 days. So it's earthquake and the number of days is my ratio. How many days must pass, I don't know, to experience another 7 earthquakes? So this ratio is earthquakes to the number of days, and the question is, how many days must pass? So I don't know, I use the variable there. To solve, cross multiply, 1x one way, 7 times 125, divide by 1. That will give us the value of x, which is the number of days. 7 times 125 is 875 days. So very little chance of an earthquake to happen. The risk factor of the Apollo 11 landing was given 5% chance of success. That is 5 out of 100. 5% chance. How many trials would they have to perform in order to guarantee 20 successes? So the success is 5 out of 100 trials. Based on my ratio, The question is, how many trials, I don't know, would guarantee 20% success? So my variable is how many trials? Cross multiply 5x one way across equals 20 times 100. Multiply 20 times 100, then divide by 5. And that will be the x value, the number of trials. So 20 times 100, 2000, and then divide by 5. That's 400 trials. And question number 8. The chance of getting 10 heads in a row by flipping a coin is 1 out of 2 to the 10th power. So it's 1 out of 2, 10 times. 1 out of 2, 1 out of 2. If you multiply that, is 1 out of 10,024. So to get 10 heads in a row, that's a very rare chance. Question, how many trials will it take, I don't know, to get 10 heads in a row 5 times? That's very, very, very low chance. So it has to take a lot of trials to get that possibility. Let's see, how many trials would that be? 1x one way across, 5 times 1,024, multiply, and then divide by 1. And that is going to be 5,120 trials. So if I want to get 10 heads in a row 5 times, it would take 5,120 trials.